as with all these other problems, we're gonna take the first order partial derivatives in order to find the potential critical points, because the critical points are located where the each partial derivative is equal to 0. So if we just find where this equal to 0, we can have this can be equal to 0 where cosine y is equal to 0, or 4 minus 2x is equal to 0. So this can either be at x equals 2 or y equals pi over 2 or 3 pi over 2. However, this is at the interval, so this is not possible because it's just out of this boundary. And same thing here, just negative sine y is equal to 0 when y is 0 or 2 pi. Again, 2 pi is out of the interval, so you can't use it. And this 4 minus 2x is the same thing, right? Or no, it's not the same thing. You just have to pull out an x, so you can get x equals 0 or 4, and again 4 is out of the interval, so it's only the only possible values that you can have for the thing are x equals 2, x equals 2 or 0, or y equals 0 and pi over 2. And just by the just how it works out through the algebra, you know that you have to use 2, because if this is 0, then that means this entire thing is 0. Instead of making this 0, cosine y is 0, then this wouldn't be 0. Same thing for this, because again, if you made y something else besides 0, then this or yeah, this would be 0, but this wouldn't be 0, and if you had x as pi halves. So regardless, you know that 0 is a critical point of the function, and this value is to 4 at this point. So now you just have to plug in all the boundary points, and because of its just trig of pi over 4, you get the same values for all these 3 root 2 over 2, and so that means you know that the absolute max is 4, and the absolute min is 3 root 2 over 2, which is on all the peripheral points on the rectangle. And yeah, that's number 37, lesson 14.7. Thank you.